All right, we're going to discuss the perpendicular bisector of a chord. That is, if a diameter of a circle bisects a chord that is not a diameter, then the diameter must be perpendicular to the chord. And we know that the diameter is going to cross through the center of our circle. So I'm going to give these points a name. This will be point A, B, and C. And where we have our perpendicular lines here, we're going to name that O. So given AO is 3x plus 34, and BO equals negative 4, 2 minus 6x. We want to find the value of x. Well, since this chord bisects, we know that these two line segments are going to be equal to each other. That means we can set these two expressions equal to each other to solve for x. So I would set up 3x plus 34 equals negative 4 times 2 minus 6x. And again, this is because AO is equal to BO. So now to solve my equation, I'm going to distribute on this right side of my equation first. 3x plus 34. And to distribute, we have negative 4 times 2, should be negative 8. Negative 4 times negative 6x will give me positive 24x. From here, I want to get x by itself on one side of my equation. Since I have a larger value over on this side, I'm going to subtract the 3x from each side. That way I will have a positive x in the end. So 34 is left, minus 8 plus 21x. And again, I want x to be by itself on this side of the equation. So I'm going to add 8 and move it over, because what I do to one side of the equation, we do to the other. So adding up my 34 and my 8, I will get 42 equals 21x. And from here, I'm going to divide each side by 21, giving me 2 equals x. And if I wanted to find the value of BO, then of course I'm going to plug that 2 into my expressions. So for AO, I would get 3 times 2 for x, plus 34, 6 plus 34, and then of course 40 will be AO. And of course we want 40 on this side as well. So if I have BO equals negative 4, 2 minus 6 times 2. So negative 4, and then 2 minus 12 is going to give me negative 10. I multiply negative 4 times negative 10, and I will get 40. Another example of our perpendicular bisector of a chord would be that if I had this, and let's say I had A, B, and C, and then angle ABC equals 5 times 2x plus 3, and I wanted to find x. Let's go ahead and separate these two problems so we don't get confused. So now that I know about this theorem, I'll put a center point, that the perpendicular bisector of a chord creates these perpendicular lines, then I know that angle ABC is equal to 90 degrees. So 90 equals 5 times 2x plus 3. Distributing my 5 in, I have 90 equals 10x plus 15. And from here, of course, I wanted to get x by itself, so I'm going to subtract 15. giving me 75 equals 10x. Divide by 10. And 7.5 equals x. And then once again, I can plug that into my equation to find the angle, or to find x. That would be equal to 90. So let's do that to make sure that we're right. 5 times 2 times 7.5, because that's where our x would go, plus 3. 5 times 7.5 times 2 is going to give me 15, plus 3. And then 5 times 18, and that's going to give me 90. It's